Well, a warm welcome to anyone joining. Thank you for being here. As usual, go ahead and get yourself ready with a notebook. Grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have another SAT style problem in the topic of algebra, and more specifically, this recent trend of mine to talk about binomial expansion. Okay. If you've seen the other few videos like this, you're pretty used to this presentation style of the problem. They all pretty much appear more or less like this. Go ahead and give yourself about 2 minutes or so. Try to solve this problem on your own first. And then if you get stuck or you finish and you want to check your work, feel free to unpause the video, come back and see how we did it here. Okay, getting started. We have this given information, of course, and a little bit more given information, the value of x, y. If you've been watching the last few, you'll know that this is kind of setting you up for the binomial expansion, but even if you haven't seen the last few, we're asked for the value of x minus y squared, which possibly would make you think, okay, we don't need to solve for x and y, but we just need to find an expression x minus y, get its value, and then square it. But from the information we have here, it would be very difficult to get to x minus y by itself. So what we have to do is we have to notice something. You might have this in some way memorized, that x plus y all squared and x minus y all squared, they're rather similar. They're different in one key way. The positive in the middle is the negative in the middle, and their expansions are very similar as well, but are also different in one key way. The expansion of x minus y squared, much like the inside, is different with the minus. The expansion is also different with this minus instead of a plus, but everything else is the same. Now, why is this so useful? Why is this so important? Well, on the one hand, I have x plus y's value. So I do have 5/3, and I can square it. On the other hand, I would like to know x minus y squared, which is this entire expansion, which really isn't that far off from what we're given. What's the connection between what we're given, squared, that is, x plus y squared? What's the connection between that and what we're after, which is x minus y squared? Well, if you just take a notice that the difference between these is the middle term, 4xy. That's how much more this expansion is than this expansion. So I could write x plus y squared is equals to x minus y squared plus 4xy. And if you notice it, that's absolutely true, right? Like if I added 4xy to this, it would become positive 2xy, and then this would become x plus y squared. So given that information, now we found a way to use xy. It probably was no surprise at this point how to use xy, or that xy indicated needing the binomial expansion in some way. We've been using xy several times in the last few videos. Okay, so let's plug in our given information now. We can use 5/3 in place of x plus y. And I guess in order to find out what x minus y squared is, I'll have to subtract for xy, and this is going to be equal to what I'm looking for, x minus y squared. Now we're given that 4xy, or rather we're given that xy is 3 over 18, so let's go ahead and plug that in. The fraction works, it looks messy, but I'm sure it'll be fine. 3 on 18. Well, this translates to 25 over 9. And this translates to, what can we call that? Let's make this a 9 denominator by reducing by only 2. You can reduce it further if you'd like to reduce the 3 over 9, but we're going to have to inflate it once again because we need to subtract it from 25 ninths. And this is simply going to give us 19 ninths. Believe it or not, that is our answer. That is how simple this becomes once we know what we're plugging in and why. Alright, so I don't think that one was too incredibly hard, especially on the back of several similar problems that we've done. In any event, the point of these problems is not just to memorize structures like the binomial theorem, but to actually use them critically, use them effectively. And in this particular problem, I wanted to emphasize how algebraically connected x plus y squared and x minus y squared are. You might be in a proper habit of just knowing, okay, this one has a plus, so it's a plus, and this one has a minus, so it's a minus. That's great. I'm glad that trick works, but I really want you to understand the connection because it allows us to solve problems like this, where we have to jump from an expression that's not so obviously connected, x plus y, to x minus y squared. Okay, and doing that fast and effectively is the best way to be successful on the SAT. Alright, I think that's enough blab out of me. I'll see you guys next time.